Welcome to this explainer. Okay, if you have stepped outside recently, you know exactly what we are dealing with. Today, we're unpacking the sheer mechanics behind this inescapable, sweltering heat that's basically dominating the headlines and honestly, our daily lives. We are going to get into the science, the hard data, and most importantly, how we can all adapt. Let's get to it. So, why does the summer heat suddenly feel impossible to escape? It's a question literally millions of us are asking right now as we face these stifling temperatures all over the globe. I mean, it feels way less like a typical summer and more like walking into a preheated oven that you just can't turn off, right? Well, this isn't just your imagination playing tricks on you. There is a very real, very measurable atmospheric phenomenon at work here. Okay, let's dive into this data because it is wild. 132 years. That is a massive stretch of time. Yet March of 2026 shattered extremes to become the contiguous United States' most abnormally hot month in over a century of record-keeping. It started in the Southwest and just rolled right across the rest of the nation. When we see numbers like this, we know for a fact we aren't just dealing with a standard summer warm-up. We are dealing with something much, much more intense. Section 1. Anatomy of a heat dome. So what is it? At its core, a heat dome is a massive, stubbornly stationary, high-pressure system hovering right above a region. Climate scientist Zachary Lab notes that these systems act essentially like atmospheric lids. They trap and heavily amplify surface heat, which gives us these prolonged, baking, dry conditions that linger for days instead of just, passing through in an afternoon thunderstorm. Think of it kind of like a giant atmospheric traffic jam. First, you get this northward flow of warm air. As that air pushes in, the high-pressure system forces it to sink, compressing it. And this sinking action directly drives up the atmospheric pressure, which in turn causes the temperatures to completely spike. It's this compounding loop, and the heat gets securely trapped right where we live. And this brilliantly illustrates the scale of the problem. Dr. Jennifer Francis from the Woodwell Climate Research Center paints a striking visual for us here. She points out that because warm air expands, this incredible regional heat essentially forces the layers of the Earth's atmosphere to physically bulge upward. It's literally like a lid swelling up on a boiling pot of water. That is exactly what is happening to the sky directly above a heat dome. Section 2. A global temperature crisis. Let's move out and see how this builds, because this atmospheric bulging is a relentless global march. Following the U.S.'s record-shattering March, May brought absolutely scorching extremes to India and had a massive impact on the French Open over in France. Then, by mid-June, Europe was baking under these unseasonable 40 degrees Celsius, that's 104 degree Fahrenheit highs. So we are looking at a sequential worldwide phenomenon. And the immediate threat is ongoing. Right now, a long heat wave is expected to slam the eastern U.S., while the Southwest is already navigating 100-degree temperatures. It's an extreme weather pattern dominating North America right through the 4th of July holiday, and it's even placing major international events like the upcoming World Cup directly in the crosshairs. Section 3. The climate change connection. Now, when looking for the catalyst behind these intense systems, our source material points to the scientific consensus around human-driven climate change. Dr. Francis outlines that actions like the widespread burning of fossil fuels, coal, oil, gas, and significant deforestation have increased the concentration of heat-trapping gases in our atmosphere. And according to the experts, this is fundamentally altering our global weather patterns. So the crucial point here is our shifting atmospheric baseline. When you compare them to historical norms, experts in our sources note that climate-driven heat waves are evolving to become far more severe, they last for longer durations, and they occur much more frequently. This shift is actively accelerating secondary crises, like severe droughts and the wildfires associated with them, exactly as scientists had expected. Section 4. How to stay safe. Let's zoom back into what you can do. When extreme heat hits, physiological mitigation is critical. We're not just talking about comfort here. It's about preventing rapid core temperature spikes. Your actionable checklist? Make sure to stay fully hydrated. Completely avoid physical exertion and outdoor exercise during the heat of the day. Find shade, seek out air conditioning, and actively utilize local city cooling centers or bodies of water, like pools, to force your body's temperature back down to a safe baseline. Now, what's really interesting here is the focus on the night. While the midday sun obviously gets the most attention, Zachary Labe issues a surprising warning. Nighttime humidity is a severe hidden danger. High humidity drives up the wet bulb temperature, which actually prevents sweat from evaporating. And since that's your body's primary cooling mechanism, if your system can't recover overnight, heat stress compounds rapidly.
This makes access to nighttime cooling absolutely vital for survival.
So, what does this all mean? The data shows us a very clear trajectory. As these massive, atmosphere bulging heat domes become our new normal, a critical question remains. How will our infrastructure and our communities adapt to protect ourselves in a rapidly warming world? It's a lot to think about. Thanks so much for joining me on this explainer. Keep questioning and please stay safe out there.